Okay, we're gonna take a quick little lesson here, and this is kind of just a throw-in section. You guys explored a lot of Chapter 10 in your last class, not this section, so we just kind of throw it in the second half of Chapter 9. It doesn't really fit with exactly what we were doing in Chapter 9, but just a little extension on something you guys have been working with for a long time. So we're gonna be looking at systems of nonlinear equations. So you guys have done systems of equations in Algebra 1, Algebra 2, College Algebra. So basically, does it have one solution? Does it have no solutions? Does it have infinite solutions? So we're trying to find where lines hit each other. So now we're going to look at nonlinear ones. So it's not going to be just lines. It could be parabolas, cubics, circles, whatever. Okay, so trying to figure out total solutions here. So a few little hints. If the pictures are easy to graph, then just at least do a rough picture. It doesn't have to be accurate, but it'll at least tell you how many equations are, or I'm sorry, how many solutions are possible. And then the whole idea of the extraneous solutions. So you can get solutions that don't necessarily work through your solving. So be sure you go back and check those solutions. Okay. What are all the ways we have for solving a linear system? So we can graph it on a sheet of graph paper or in our calculator. We can do substitution, or we could do elimination, which is the same thing as a stack and add. Okay, we're going to use the exact same things, strategies, with these nonlinear systems. So the graphing can work, but we want to back it up algebraically, and substitution and elimination are really going to be our best bets here. Okay, so if I give you this guy here, so 3x minus y equals a -2, and a 2x squared minus a y equals 0. Little hint, be super careful when you're spacing these terms out, because right now you have x and x squareds on top of each other. Realize those won't cancel at all. So I'm going to pick one way here. I'm going to notice that this is a -y, and this is a -y. If I do stack and add, these guys should just cancel right out of there, but I'm going to have to change it first. So I'm going to take this one, I'm going to multiply it by a -1. And be sure that that guy goes the negative sign goes all the way through. So then we have to stack the second equation underneath it, but there's no x term. There's a 2x squared term, so make sure that gets offset here. So you can add in a 0x if you want. It's not going to hurt anything. Now I can do stack and add these two equations straight down and see what happens. So 2x squared minus a 3x, y's cancel, which is exactly what I want, and then I get a 2 here. So I've turned this into a quadratic. Remember, we don't want to solve quadratics this way. You guys were never taught that, so make sure we skip that. So we have all these different ways to solve quadratics. If you have a and b terms, you want to set them equal to 0. So move this 2 over to the other side. Now it's a quadratic. You could do quadratic formula. I'm going to try and factor it, though, just to see. Okay, so that'll give me 4x, that'll give me 1x. So if I make that negative, it'll give -4 plus a positive. So that will work. Now we're going to get two solutions out of this. We're going to get x equals -1/2, and we're going to get x equals 2. So just like when you did linear systems, however you did it, substitution, elimination, you always got one of the variables. You have to go back now and find the other one. But this is different because we're actually going to have two separate points. So when I plug in a -1/2, let's see what happens. I'm going to go back to the originals here, and I'm going to use the linear one because that's pretty, it's a whole lot easier. So I'm going to use this here. So I just switched the negative y and the negative 2 to make it easier on us. And this comes out as 1/2. If you go plug a 2 in there for x, this becomes 6 minus y equals negative 2. So and this y comes out as 8. So there's our two solutions. So I said the extraneous solutions are possible. It usually happens when you're squaring things, you're getting rid of square roots, that you get those extra solutions. But let's just check. So what I'm going to do is solve each of these for y and see what a picture would look like. So that's y equals 3x plus 2, and this is y equals 2x squared. If you were to graph those, there's your line, 2x squared. Starts at the origin, is a little bit skinnier. So you would get two solutions. You could check it in your calculator as well, but that's what we would get. It's right there. Okay, here's the second one we want to look at. So it's got x squareds and y squareds in both of them. So we're not exactly sure what kind of shape it is, but you could graph it if you wanted to solve for y. You probably need some graphing software, unless you added in the plus minus in your calculator. The last one we could have done with substitution. It wouldn't have been too bad. We could have taken this here and just thrown this in there, and we would have ended up with the same quadratic. This one you definitely don't want to do any substitution. It doesn't look like anything's really easy to solve. So I'm going to look at it and notice again, things aren't stacked up perfectly. You got x squareds on top of y squareds. We want to make sure we take care of that. So I'm going to try and get rid of the y squared and the negative 2y squared. But first, I'm going to reorder everything here. I'm going to take this 5 and just swing it to the other side for simplicity's sakes. Okay, it's not going to really change your solution. So I'll look at it and I'll say, okay, what if I multiply this entire equation here by negative 2? Make sure that gets all the way through. We have the opposite same amount of variables, so we do this just like you guys have been doing for a while. You get an x squared equals a 3. So the trick with this then is then saying x equals plus or minus square root of 3, okay, because we can have both values there. So again, we have to go figure out what the corresponding y values are going to be. So get rid of this stuff so we have some more room to work with. I'm going to substitute it right in there. Okay, that one seems easiest to me. So a 3 times a square root of 3 squared minus a y squared equals 1. Just switching places with those two there. So that means y equals plus or minus 2 square root of 2, because we don't want to leave square roots of 8. Okay. Now notice if I plugged in a negative square root of 3 here, when I squared it, I'd still get the exact same thing anyway. So there's my 4 solutions. How you should write those guys, the book's answer here, we'll write them all out as each combination. So positive, 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 negative, negative, positive, negative, negative. You could also tell me and that'd be acceptable as well. Okay, we're going to go over to part 2 for one last problem.